in the stop. In the stop. Now I am going to explain why. My friend, look at this. This momentary switch, this momentary switch, this momentary switch have the same function of this. Battery, ignition, and start. You can replace the ignition switch for those three momentary switches. This one will be this one. This one, the preheat. And this one, start, stop. You know, you can replace this delay for this. At the end of the diagram, we are going to eliminate that one and we are going to connect the switch. In other words, you have a generator or engine here in the engine room with the control box, and you can start the engine here in the engine room directly on the switches. Or you can start the engine in the pilot hand with the ignition switch. You can connect both of them in parallel. Can I start the engine here in the engine room and stop the engine on the flybridge?
Yes.
Or vice versa?
Yes. Yes.
Yeah?
Yes.
I'm going to explain the procedure to connect that. Okay, my friends. Great. Yes, the power enter in the stop. The stop switch is normally, stop is normally close. Normally close. Normally close. What about preheat? Normally open. What about the start? Normally open. Momentaries, but this is normally closed. What is the meaning of that? If I don't have power, what happens if I check continuity between this and this? Beep. Because it's normally
Close.
closed with no power. This is normally open and this is normally open. Right? Okay. The preheat is the same than ignition. Preheat is ignition. It's the same. Okay. I have power here in the normally closed. Okay, because it's normally closed, I have power here, no? And I am going to connect this with this to bring power for the preheat. Okay, the first step is we are going to start the engine. We are going to start the engine. That's the number one. Okay, I need to start the engine. Of course, here I have the switch selector, and I have the big power entering here. You remember? And that big power pass here. Yes or no?
Yes.
Alright, and I have one of those signals positive and the other negative. Which is positive? Positive. I am going to put that one negative, no problem. Okay, I am going to start the engine. Normally, in normal conditions, you send the signal to activate the crank relay coming from ignition. In this case, it's from preheat because it's the same. Preheat, and I send the signal here. Yes or no? And now I pass the current here on the start motor. But the current pass to the other big terminal. The current in this moment is moving the motor internally. No, I have current at the input, but I need to close the gap. The gap is coming, the gap close if you bring the signal yellow-red from start position. Okay, I'm going to bring the signal yellow-red. Pay attention. When I have power here, I can send power immediately here, and after that, with the yellow-red, I bring the power here for the signal of the start motor, no? But this connection is not yet. Okay, look at this. When I activate preheat, I bring the signal here to the crank relay and I pass the big current. Now I need to send the yellow-red signal. But I am going to use a relay for a start. This is the start relay. I am going to use other relay for run relay. And I am going to use other relay to stop relay. Okay, in this one, in the button, I have constant power entering in which terminal is this? Excuse me? 30. In 30. And in the output, I am going to send the yellow-red signal to activate the start motor. Of course, I need activate the coil. I need activate the coil of the relay. I am going to activate the coil of the relay, look, with a signal coming from the start momentary push button. Look at this. I am going to start the engine. Pay attention. I press the preheat. I keep the preheat pressed. And I press start. And now the start motor is spinning? Yes or not?
Yeah.
Yes, because I have preheat and start. Excuse me. The start motor is spinning, the engine is cranking?
Yes.
But the engine start?
No.
No, because the engine needs fuel. That's correct? Okay. In this moment it's cranking, but not start. I am going to bring
Fuel.
fuel. Okay. Alright, now it's cranking, no problem. Let me check something. I am going to bring also constant power here for this, for the run relay. With the run relay, running, I want to feed the fuel pump, the fuel transfer pump, fuel transfer pump, and this is the fuel injection pump, and this is the injector, and this is the solenoid. This is the stop solenoid, no? Okay, and the solenoid needs one positive and one negative. Okay. The transfer pump is the pump that you hear in your car when you select ignition. You hear. This is the pump that brings fuel from the fuel tank into the fuel injection pump on the engine. This is only transfer from the fuel tank into the engine. Yes or no? This is the transfer pump. This is considered low pressure pump, only to bring the fuel from the tank into the engine. Good? That's the pump that you hear when you select ignition. And after that, if the fuel enters here and the solenoid is open, the fuel enters. If the solenoid is closed, the fuel no enter and the engine no start. Good? Alright. Pay attention. I am going to send from the output of this relay one signal to activate the transfer pump and bring the fuel, and at the same time one signal to activate the solenoid and allow that the fuel enter in the fuel injection pump. Good? Okay. Look at this. How is the connection between 30 and 87? Normally? Open. In this moment, the fuel transfer pump and the fuel injection pumps are running? No. I need signal. Okay. I am going to bring from the preheat signal here. And now I am going to try to start the engine again. Follow me. I press preheat. I bring power to the big one. I press start. I send signal to the start motor. Yes or not?
Yes.
The start motor is cranking?
Yes.
Yes. And the fuel is entering in the engine?
Yes.
Yes, because look, I bring power here, the fuel transfer pump, bring the fuel, and the solenoid open, and the fuel enter. And because the engine is cranking, the motor start. Wow, the motor is running. What happened in that moment? I can remove that finger.
No.
Yes, the start. You don't need, because the engine start. And now, can I remove that one?
No.
Why not?
Because
If you remove that one, you interrupt that one, and you don't have fuel, and the engine stops. Ah, I need to stay over there 5 hours. That's good? 5 hours over there?
Yeah.
How can you solve that issue? Excuse me?
The other relay.
With power coming from the output of the alternator. Hey, Bobby! When the alternator of the engine produces your own current, you can remove your finger and the engine continue. For that reason, in the majority of the engine, you need to stay with that button 10 seconds, no? Until the alternator produces power, you remove the finger, and finito, the engine is running. Good? Okay. We are going to install here the alternator. You remember? Guys, you have here excitation, and you have here sense, and you have here positive output DC, and you have here output AC, and you have here ground, and you have here the light. You remember? You remember that alternator? The Motorola, correct. Okay, look, from the output of the alternator, how much is the voltage here when the alternator is running? 12?
13, 14.
In between 13.6 and 14.2. No? And what is the color of that cable normally?
Orange.
Orange. I bring my orange here, 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 and here. Okay, look at this. Press, press, follow me. Press, press, crank, and the engine start. I remove that one, the engine continue running. 10 more seconds, I remove this, and the engine continue running because I have power over there. Bingo, the engine is running. You like that?
Yes.
This is that's simple, no? And you use those relays, start relay and run relay. Pay attention. I have a question. I have one inconvenience. Look at this. During the preheat, you remember that the DC output is coming from the stator. You remember? Not the rotor. The rotor is the excitation with the magnet. You remember? And the stator produces the AC output and is rectified into DC, or the alternator. During the preheat, when I press that one, I bring power here, and I bring power here in the output. It's good?
No.
I damage the winding of the alternator. How can I protect the alternator for that issue? Correct. I install one diode here to protect. This is the only diode that you have in the harness to protect the alternator. Okay, puppies, the engine is running. Now I need to stop the engine. Stop the engine. I am going to do this trick. I am going to pass that one. I am going to pass that one. Pay attention. Follow me, follow me, follow me. In this moment, What happened with that switch? It's normally closed. What is the meaning of that? You have constant power here, no? Because you have constant power here, that relay is constantly activated. This and this is connected all the time because it's powered all the time. What happened when I press that button? I interrupt that current. And what happened with this connection? Is open, and I don't have fuel and fuel. And finito. Stop. Good?
Is there a certain color for the fuel transfer pump wires and stuff?
No, depends on the manufacturer.
Yeah, every manufacturer has their own color codes. That's why it's important that you have the service manual to see what the color codes are.
But this is the spaghetti in the control box. Difficult? The simple one. Now the start motor, the alternator, everything is connected. But we are going to connect more elements. You remember that in the video related with that harness, I explained the difference in between sensors and switches, no? What is the difference between sensors and switches?
Sensors send signal.
The sensor is used to send the signal for
The
the
switch.
gauge and also to send the signal for
Switch.
the computer of the engine. What is the name of the computer? CPU, Control Power Unit, or CPM, Control Power Module, no?
ECU as well, right?
Correct.
Or MFDs.
What is the other name?
MFDs? 'Cause
Or
I saw that.
powertrain module.
No, I saw that.
Depend of the
Yeah, Mark
manufacturer.
calls it
They call different the computer. But it's the computer. Excuse me. With the sensor, I send signal for the gauge, and also I send signal for the computer. Because the computer needs that signal from that sensor, temperature, or oil pressure, or RPM, yeah? And with that signal, the computer compute some calculation to produce 3.7 or 1.3 or 2.8 for that equipment. You know? You understand? That's the circuit. All right. In the engine, you have 3 switches used to kill the engine. In any type of marine engine, you have 3 switches to kill the engine. Give me one switch.
Temperature,
Temperature,
oil
oil
pressure,
pressure,
fuel.
and exhaust gases temperature. Exhaust gases temperature, oil pressure, and coolant temperature. Coolant temperature, no raw water, coolant. If the temperature of the engine pass the limit, that switch open and interrupt that cable. If the pressure of the oil internally in the motor decrease the limit or pass the limit, interrupt that cable and stop the engine. Or if the temperature in the exhaust elbow, you remember, pass the limit, interrupt that one and interrupt the fuel and stop the engine.
I have a question. Is that wired in series or parallel?
What wire?
The sensors.
Parallel.
Series.
In series, all of them in series. And now we are going to connect those sensors. Pay attention. To kill the engine,
Oh, it's serious to the engine. Parallel to the unit.
you have 3 sensors. Switches, sorry. Oil pressure, switch. Coolant, temperature, switch. And exhaust gases, temperature, switch. Some engines only use this and this. Some engines use all of them. Depend on the manufacturer. Right? Okay, I have a question. where is located the oil pressure switch and the oil pressure sensor? Where are located those switch and sensor?
Next to the filter.
Excuse me?
Next to the filter.
In the bracket, the metallic bracket where you have the oil filter. In that point, you have one hole for the sensor and other hole for the switch. No, Jolly? One, the sensor is used for the instrument, for the control, and the switch is used to kill. Where is located the coolant temperature sensor and the coolant temperature switch? In the thermostat housing. Where the thermostat is located, in that point you have one hole for the sensor and other hole for the switch. Nice, huh? It's clear, my friends?
Repeat that again.
Okay. You have always sensor and switch. Sensor for computer engage and switch to interrupt. You have three combination: oil pressure switch sensor, coolant temperature switch and temperature sensor, and you have a exhaust gas temperature sensor and switch. In some cases have dual function, switch and sensor, the exhaust gases. Thermostat open and the coolant goes into the radiator, and in front of the radiator you have fan. And what happened with the coolant? The temperature of the coolant decrease and enter again in the engine because the circulating pump or coolant pump circulate that. And once again, what happened when the engine is too cold? The temperature of the coolant is low temperature. What happened with the thermostat? Close again and the temperature rise. And all the time the thermostat is opening and closing, allowing that the coolant goes out and enter and goes out and enter and goes out and enter. You know? Okay. The thermostat, the bracket, the metallic element where the thermostat is located is called thermostat housing. In that point are located the sensor and the switch because this is the point, the breaking point where the temperature of the coolant changes dramatically. For that reason, those sensors are located over there.
If you watch the gauge, you can actually physically see the gauge.
The question is, like, you have a sensor, right? Why we have a switch near to this housing if we, like, why we have a switch?
Oh yeah, pay attention. I need interrupt when the temperature pass the limit. How I know if the temperature pass the limit? Because I have a switch with a sensor element in the bottom that sense the temperature of the coolant. When that temperature pass the limit, the contact open and interrupt the current.
Protects the motor.
Okay. So, but you said it's going to be separate. Sensor
Oh yeah, it's here and here,
switch.
not together. It's
Usually
here.
one side or the other. They're almost.
1 ounce, one side. Now in the shop I can show it to you. One in one side of the and other in the
So
other
remember the
side. Or
switch-
pretty close.
The switch. The purpose of the switch is to protect the engine so you don't keep overheating.
I get it, but like if you have a sensor, the sensor sends a signal to the computer, and computer can activate the relay.
No, but this is later.
Okay.
Don't confuse with that.
Okay.
This is later. In 2 weeks, in
Gas
summer.
lane will get more into these.
Now I am going to install in this harness the switches. In the class of diesels, we are going to do the same picture and we are going to add the sensors. Right? Okay. I want to kill the engine with the oil pressure switch. Where should be located the oil pressure switch? That's the switch. And this one have a thread. You have the switch, the switch over there, Mama? No?
No, it's on the, it's on the class control.
And that thread enter in the bracket where the oil filter is located. If the pressure decrease the limit or pass the upper limit, what happened? And interrupt the current for this and this. This is oil pressure switch. No sensor, switch. I am going to install the coolant temperature switch. Where it should be located? Coolant temperature. and the coolant temperature switch located here. If the temperature pass the limit or decrease the limit, open and interrupt and kill the engine.
When the switch goes off, the fuel injection pump sends a signal to the computer to shut off the engine.
No, pay attention. When this one is open, that element, the solenoid, no receives signal and close, and no more fuel enter, and the engine. Because no fuel.
Right.
You have to put two options to stop an engine. If you cut the fuel, or if you cut the air. If you cut the air, stop immediately. For that reason, if you are inside of the boat and you in the engine room working and you see fire, you need to stop the engine quickly. The recommendation is remove the air filter and plug it. Cover the input of the air and the engine stop immediately. Yeah? Remove the air filter and with a table or piece of wood, cover and the engine stop immediately. It's quick, no? You interrupt the air or interrupt the fuel and the engine stop. In this particular case, we are going to stop interrupting the fuel. That's the most common. Some manufacturers, like Detroit Diesel, they interrupt the air. They have a wheel that closes the intake manifold, no more air enter, and the engine stops. It's a
You
design.
put coolant temperature to the,
Coolant temperature switch.
that goes through the fuel line?
Coolant temperature switch in the in the thermostat housing is located over there, and interrupt the current and no more fuel. You interrupt the current to cut it, the flow of fuel.
So all of those are killing the fuel.
Yeah, and also the exhaust gas temperature switch is located here for the same reason. Right?
Just knowing that now, if you have a bad switch, you can think about, hey, I go to turn it on, I got no power going to the.
This
fuel.
is, excuse me, exactly. This is the switch that the people say, bypass that switch. And it's, yes, if you bypass that switch,
Your car's gonna blow.
Yeah, you damage.
right now the engine is running constantly. But what happens if the oil pressure decrease and decrease and decrease and decrease and decrease? You destroy the engine. You know? For that reason, the solution is not bypass the switch. The solution is verify what happened. Later we are going to learn what happened. For what reason the oil pressure decreased dramatically. There are millions of possibilities.
So I'm getting a little bit confused in the oil pressure switch. Is you press it manually, or does it like a sensor? Does it turn off by itself?
It's like a it's under pressure. It's like a spring. It's like
Okay,
going
you
around,
explain.
and what happens is the pressure pushes on the spring, allows it. If it loses pressure, it loses the contact.
I am going to make the drawing.
And they both work the same between the oil
And the temperature
is the same.
is the same. It's just one's using pressure, the other one's using. What happens to a metal when it gets hot? It expands, right? So what it does is it shorts it out and cuts it on the temperature side.
Look, my friend. This is the oil pressure switch. Hey, follow me. This one is bolted on the block where the oil filter is located. Is bolted over there. And when the engine is running, the oil passes over there at high pressure. If the pressure passes the limit, what happens with the oil here, with the membrane? And they are normally open or normally closed. This one is normally open. When the pressure passes the limit, what happens? Close here, yeah, or vice versa. Yeah, it's like this. Interrupt or close. This one is normally
Open.
open. There are other ones normally closed, and it's like this. You need creativity, guys.
I like it.
Yeah? Interrupt. Good? No? Confused?
No.
Now you can receive a phone call. Hi, my name is okay, go to this cable from the run relay, from the stop relay, blah, blah, blah. For that reason, next week, we have a troubleshooting on the shop with Danny, and we are going to ask questions about this. Probably we can start one engine and show to them. Yeah, okay, guys? No more questions? Finito?
Well, I want to show you a couple things on the screen.
Okay.
Professor, real quick, can you draw the connections again one more time for the alternator? The AC output's gonna go to your tachometer.
Oh, that one.